Hi there. We're going to look at average value today. Now, if this is the first time you're seeing my face, hi, my name is Dr. Marissa May. I am on a mission to help students feel successful in their math classrooms. And I do that through resources like this video, working through some examples to help you understand. If you will, go ahead and hit that like and subscribe button. That way you get a notification every time a new video is posted. And if you need other resources or other math classes, feel free to leave a comment below. I'd be glad to help in any way that I can. For today in this video, we're going to look at the average value of a function. So the first question is, how have we found average velocity prior to this? Well, we did that by finding the difference in the position over the difference in time. So we found the position at the end minus the position at the beginning, and then we subtract it over the amount of time that it took. Question then, how have we found average acceleration? Well, that we did by finding the change in the velocity. And my physics people, this is going to be very natural for you, okay? Especially if you took a non-calc based physics class. So the question is then, let's take a look at what 1 over b minus a, the integral from a to b of the acceleration. Now, if we take the antiderivative of the acceleration, we're going to get the velocity. And we're going to plug in the bounds. Now, doesn't that look very familiar, right? So this finds the average acceleration. Take a look at what we did. We found the integral, 1 over b minus a, times the integral of the acceleration, and that gave us the average acceleration. Now, if we do it with the velocity, 1 over b minus a, integral from a to b of the velocity, then of course we would get the 1 over b minus a, and then we're going to get the position, because the antiderivative of the velocity is the position. That's going to be our average velocity. So in order to find the average value of a function on the interval, so if you want to find the average value of the acceleration, then you'll do 1 over b minus a, the integral from a to b of that equation. I'm just going to put f of x here. So if you want the average value of any function, then you can use this formula. Now, let's find the average value of this function on the interval from 1 to 3. So I'm going to do 1 over 3 minus 1, integral from 1 to 3 of the function, x cubed sine squared of x dx. And we're going to use the calculator to calculate this integral. Okay, so let me switch our view so that we can see the graphing calculator. There we go. So I'm just going to do the 1 over 3 minus 1 in my head. So that's 1/2. And then I'm going to move to the right. And now let me do the integral, okay, from 1 to 3. And then let me put in the function x cubed square root of, watch the parentheses here. Oh, and I forgot my dx. There we go. And so we get 5.848. Now, pretty simple when we're looking to find the average value. We can definitely use an fint, but we also a calculator to find the integral. But let's do it also a non-calculator way, just in case this might show up maybe on the non-calculator part of the AP exam. So if we're finding the average value of this function from 2 to 6, so we'd have 1 over 6 minus 2, integral from 2 to 6 of 2 minus 4x dx. That would give me 1/4. Then let's do the antiderivative. So the antiderivative of 2 is 2x. The antiderivative of 4x is 2x squared. And we're going from 2 to 6. So now we would plug in our bounds. Let's plug in the 6 first. That would give me 2 times 6, which is 12, minus 6 squared is 36, times 2 is 72. Now minus, then we have our 1/4, and now we're plugging in 2. So 2 times 2 is 4, and 2 squared is 4, times 2 is 8. So that gives me 1/4 times negative 60 minus 1/4 times negative 4. So this gives me negative 15, and this gives me minus negative 1. So that gives me negative 14. So you can see that we actually can calculate the average value with or without a calculator, depending on that function, and can we get the antiderivative of it. Okay, let's take a look at a word problem, which is probably the way we see it happen most in the AP exam. So we've got a ski resort using a snow machine over 24-hour period. The volume of snow added to the slope per hour is given by this function. The rate at which the snow melts is given by this function. Both S and M have units of cubic yards per hour measured in the hour from 0 to 24. At time t equals 0, the slope holds 50 cubic yards of snow. So A asks for the total volume of snow added to the mountain over the first 6-hour period. So this one's just going to be an integral. So we're going to do the integral from 0 to 6 because we're only looking at the first 6 hours. And we're only doing the snow added. So that's our S. That's 24 minus t sine squared of t over 14, and that's dt. Let's take a look. We're going to have to do this on the calculator. So I'm going to switch our view. And I'm going to go ahead and clear this one out and type in ours. So I got it typed in, and it looks like we get 142.413. Now let's think about the units on that. This is total volume, so that's going to be cubic yards. Okay, now as we look at B, we're asked to find the value of integral from 0 to 6 of m of t and 1/6 of that same integral, and then explain what each of them means. So if we find the integral from 0 to 6 of m of t, again, let's put that in the graphing calculator. And it looks like we get 81.823. Let's think about this. This is the integral of m of t, which m of t is the rate the snow melts. So this is going to be in cubic yards. And I apologize, it's 823. Again, cubic yards. This is the total snow melted. In the first 6 hours. Okay, now if we put the 1/6 over there, and I really want you to think of this as 1 over 6 minus 0 of the same integral, we're just going to take that answer that we got before, and we're going to divide it by 6. So let's see what we get when we divide that by 6. Oops, sorry, I think I multiplied it by 6. Let's see. There we go. You get 13.637 cubic yards, and we're dividing by 6 hours, so that's per hour. This is the average value of snow melted in 1 hour. You even probably could say per hour. Okay, let's switch our view back then. We've got a few more questions to answer here with regard to this particular problem. So is the volume of the snow increasing or decreasing at t equals 4? So what we need to look at is the equation that talks about the amount of snow total, okay? So we've got we can look at the amount of snow. We started with 50 cubic, then we added the snow. So we got the integral from 0 to t of s of t dt. And then we've got to subtract the snow that melted. Now, if we take the derivative of this to find if it's increasing or decreasing, all I need to know is the derivative positive or negative at t equals 4? So if I take the derivative of this, the derivative of 50 is 0. The derivative of this integral, do a substitution there, s of t minus m of t. Remember, when you take the derivative of an integral, the two cancel each other out. You substitute the bound into the equation. And now I need to know is a prime of 4, which is s of 4 minus m of 4, is that positive or negative? That's all I need to know. So I'm going to go to my graphing calculator and I'm going to type these in. So s of t, and I'm putting in 4. Okay, so that, oops, and that's right, that's s of t, s of 4. That's 23.682. And then let's find m of 4, which would be 10 plus 8 cosine of 4/3. And that gave me 11.882. That means it's going to be positive. Okay, so that means the volume of the snow is increasing at t equals 4 because the derivative of the volume is positive. Okay, now look at problem number 5 here. Now, problem 5 asks us how much snow is there after 5 hours. Now, remember, in part C, we just wrote an equation that finds the total amount of snow. So really what it's asking for is, oops, not 4, 5 hours. 50 plus the integral from 0 to 5 of s of t minus the integral from 0 to 5 of m of t. Okay, again, going to our calculator. Okay, I've already typed ours in, but I want you to see it's a lot of parentheses, okay? And to get that value of 95.335, and that's in cubic yards. Now, don't be worried when the instructions say to show your work. They're really wanting to see this equation instead of just a number as the answer. Okay, and one last problem for our snow scenario. Let's take a look. So this one's asking us to suppose that the snow machine is turned off at t equals 10. That means no more snow is being put on the uh, the slope after 10 hours. And then we want to write an equation when all the snow would be melted. Now remember, this equation that we found back in part C, that finds the amount of snow. So think about if we found that value at time t equals 10, we would know how much snow is on there at the time t equals 10 when the snow machine was cut off. Then we've got to find the integral from that point to some k value of time that the snow melted. So that would be m of t. And we want to know when all the snow is melted, that would equal 0. And again, notice that it's telling you don't solve this equation, but instead just write it. And I hope that helps because it makes it a little bit simpler. Really, you're just focusing on the analysis part, not the computation of the integrals, which we've already done some of these other parts. Now, There is a good word problem for, I'm sorry, a free response question for this particular topic, and it's the 2003 Part B, AB number 6. Um, I will link the solution to this one below because I feel like it's worthwhile that you continue to practice with AP level questions, particularly if you're going to be taking the AP exam. So I hope that helps. If you have questions or comments or anything else that I can help with, please leave a comment below. I would love the opportunity to help. Bye for now.